So now we want to talk about analyzing risk and saying that can we have more faith and a degree of certainty associated with the NPV that we've just calculated. One of the techniques that help in analyzing risk is known as simulation. Now, apart from the execution of simulation as a technique in the area of finance, what do I want to do is first of all look at a very simplistic explanation of what does simulation do, right? What are we trying to do is we are trying to predict an uncertain variable. What is the uncertain variable? The uncertain variable is definitely cash flow, because year 1, year 2, year 3 cash flow is it's uncertain. I want a technique which helps me pin down this uncertain variable, all right. So, let us get this clear that our uncertain variable is cash flow for this case. In real life, it could be your sales projection, that is you do not know what is the quantity that you will be able to sell, or maybe you are not clear about the price at which you would be able to sell. In real life, maybe your cost could be an uncertain variable, because let us say you are importing raw material and exchange rates are something which are not within your control, and hence you do not know what is the landed cost of your imported raw material, right. So, there could be a list of variables which could be uncertain. In this case, cash flow is an uncertain variable. Now, I want a technique which helps me say that in year 1 will the cash flow be 10, 15 or 20, right. Now, I want to refer to what a lot of us used to do in school days, that is play a game known as book cricket. I do not know how many of you all remember, but we used to use a book and randomly open pages, and any page that we would open was associated with making a few runs in cricket. So, for example, if I am opening page number 16 over here, since the page ends with 6, we would say that the batsman has hit a sixer, all right. And then we would close the book and open the book again, and if that comes to, let us say this is page 200, right, since it ends with a 0, we will say that the batsman got out, it is a 0. So, a page which ends with a 0 means getting out. Similarly, any other random page, page 233, means the batsman has hit 3 runs. Now, why am I talking about this game that all of us have practically played in school, which is known as book cricket, is because it is very similar to what simulation does as a statistical technique. What we were doing of the art of opening the page is equivalent to drawing a random number, right. Unless and why am I saying that random number? Because opening of a page was a random event, unless you've cheated and you've just kept on opening the same page again and again. Every time you would open up a new page and a new number would be generated. So, step 1 in simulation is generating random numbers, which you can do by pulling out chits from a box. You could ask a computer program to generate random numbers. So, Excel can generate random numbers for you. That's step number 1. Step number 2, what we did in the game was we gave each number a meaning. So, a page number ending by 6 means the batsman hit a 6, all right. So, there was a meaning associated with the number 6 with something happening in the game. Similarly, in simulation, I need to set up a relationship between the number and the uncertain variable. So, what is the uncertain variable over here? Cash flow. So, what will I have to do over here is when I generate random numbers, I will have to give each random number a meaning, and that meaning is either it means a cash flow of 10, 15 or 20,000, or it means a cash flow of 10, 15, 30 or 40,000 for year 2, so on and so forth. So, we will do two things. One is we will generate random numbers. Second, we will establish a relationship between the random number and the uncertain variable, right. In our case, the uncertain variable is cash flow, all right. And that last step in simulation is, we will keep on repeating this process for a few thousand times or a few lakh times, and hence every time you complete a simulation run, you will have an NPV, a positive or a negative NPV. So, let us say I draw out 3 random numbers x, y and z. X indicates a cash flow of 10,000 for year 1, y indicates a cash flow of 15,000 for year 2 and z indicates a cash flow of 20,000 for year 3. Now, this is one simulation run where we will say 10, 15 and 20,000 discounted at a cost of capital of 15% results into an NPV either positive or negative. So, every simulation run, what are we doing? Drawing 3 numbers, one number for year 1, second number for year 2, third number for year 3. Discount the cash flows, calculate the NPV. So, every simulation run results into an NPV. Let us say I did this 1,000 times. That means I have 1,000 NPVs. And let us say out of this 1,000 NPVs that we calculated, for example, 900 NPVs were positive, alright. So, 90% of the times we got a positive NPV, only 10% of the times we got a negative NPV. Now, when I look at my expected NPV of 4708, that is when my confidence level increases in this NPV, because my simulation results tell me that there is a 90% chance that the NPV is likely to be positive and only a 10% chance that my NPV is likely to be negative. Now, one may argue that maybe you were just drawing the numbers such that out of 1,000 NPVs, you got 900 positive NPVs. Well, then I am okay to increase those simulation runs from 1,000 runs to let us say 1,000,000 runs. So, 1,000,000 simulation runs means 1,000,000 NPVs, and out of 1,000,000 NPVs, if I get let us say 7.5 lakh NPVs positive, I still have a confidence level of 75%, right. So, I hope you get it. How does the method work? Let me repeat this for clarity's sake. Simulation as a technique has 3 steps. One is drawing out random numbers, which we can either do manually with the help of a book, with the help of drawing out chits from a box, or we can ask a computer program to do it. Second, we establish a relationship between the number and the uncertain variable. In our case, the uncertain variable is cash flow. And third is repetition. It is repetition which gives and builds this technique, because each run is a random event and the randomness is what builds confidence into simulation as a method. So, now I am going to read the case. Obviously, because we are doing this manually, we have only 5 simulation runs. So, if you notice, I have set 1, set 2, set 3, set 4 and set 5, which is actually simulation run 1, 2, 3, 4 and 5. So, we are going to do only 5 simulation runs over here, right, and say out of 5 times, how many times did we get a positive NPV and how many times did we get a negative NPV. So, how does set 1 look like? Set 1, for year 1 I have drawn number 4, for year 2 I have drawn number 2 and for year 3 I have drawn number 7. That means I opened the book 3 times, alright, and I got page number 4, page number 2, page number 7, right. Each page indicates cash flow, some cash flow for year 1, year 2 and year 3, alright. Similarly, set 2, set 3, set 4 and set 5. So, what have I done over here is I have jotted down simulation run 1, alright. For year 1, I have drawn random number 4, for year 2, I have drawn random number 2 and for year 3, I have drawn random number 7. Now, this is the first step, drawing random numbers, right. The second step is establishing a relationship between the number and the uncertain variable. So, each random number actually means some cash flow. Now, I am saying random number 4 in year 1 indicates a cash flow of 15,000. Now, what was year 1? Year 1 was either a cash flow of 10, 15 or 20. Now, why does number 4 indicate 15,000 and not 10,000 or 20,000? So, that is where a little bit of calculation comes in. So, let me show you that step. I am moving away from the screen and coming to what I call as relationship between the random numbers and the uncertain variable, alright. So, what have I done is I have reproduced this cash flow for year 1, alright, which says a cash flow of 10, 15 or 20 with a probability of 0.3, 0.4 and 0.3. I am converting this probability into a cumulative probability of 0.3, 0.7 and 0.1. That is pretty simple to understand. 0.3 plus 0.4 gives me 0.7 plus 0.3 gives me a total probability of 1, right. And did you notice that all random numbers are single digit numbers, right? Like if you go to the case and if you have a look at the case, all these random numbers 4, 2, 7, 7, 4, 9, all of them are single digit, right. And I mean, one way to look at it is this is a small book and it's a 9-page book, alright. Now, your book could run into thousands of pages or it could run into a few hundreds of pages. Depending upon that, we will prepare the range, alright. So, let me get back to this. I am converting this cumulative probability, multiplying it only by 10. Why am I multiplying it by 10? Because it is a 10-page book, alright. So, what do I get is 3, 7 and 10. And now I convert this into a range, right. So, the number 3 means I will have 3 pages associated with it, page 0, page 1 and page 2. So, my range is 0 to 2, alright. Then for 7, it means 3 to 6 and 10 means a range of 7 to 9, alright. So, one way of looking at it is 3 pages, let me color it differently, alright, 3 pages, alright, 4 pages, 4 pages and 3 pages. Which 3 pages? Page 0, page 1 and page 2. Which 4 pages? Page 3, page 4, page 5 and page 6. And again, which 3 pages? Page 7, page 8 and page 9, alright. So, a random number which is between 0 to 2 indicates a cash flow of 10,000. A random number between page 3 to 6 indicates a cash flow of 15,000 and a random number between 7 to 9 indicates a cash flow of 20,000. So, if you look at my random numbers for the first simulation run, I had 4 for year 1, alright. And if I look at this note that I have prepared, random number 4, alright, random number 4 for year 1 falls and indicates and correlates to a cash flow of 15,000. So, what did I do? I looked at random number 4, went to the working note over here and selected a cash flow of 15,000. Why? Because 15,000 relates to 3 to 6, which includes random number 4, alright, and pressed enter, alright. So, that is how I have selected the cash flow. Let me do it one more time. So, random number 2, alright, for year 2, alright. What does that mean? I will go to the working note and I am saying that this is the probability converted into a cumulative probability multiplied by 10, right, and converted into a range. Which number are we talking about? 2, and the range for 2 indicates a cash flow of 15,000. So, I press enter. Random number 2 indicates a cash flow of 15,000 for year 2 and random number 7 for year 3. I will go to the working note for year 3, alright, and year 3 random number 7 falls in this range, indicating a cash flow of 20,000, and hence my first simulation run, which wherein I generated random number 4, 2 and 7, indicated a cash flow of 15, 15 and 20,000 in year 1, year 2 and year 3. When I discount it at a PVIF of 15%, convert it into a present value, alright, what do I get is 13, 11 and 13, a total cash flow of 37,000, alright, in present value terms. So, the present value of my cash inflow comes to 37,000. The present value of the cash outflow was given in the case as 42,000. Inflow minus outflow, alright, my NPV of the first simulation run comes to be a negative NPV, alright. Now, what do I have? I have 5 simulation runs. In the first run, what did I get? A negative NPV. If I continue to get a negative NPV in simulation run 2, 3 and 4, so 4 times out of 5, I get a negative NPV, then 4 by 5 is an 80% chance that this project will result into a negative NPV, which reduces my level of confidence in the earlier NPV calculation. I hope that makes sense, right. So, what am I now going to do is, I will quickly get through one more simulation run, alright. Simulation run 2 involved number 7, 4 and 9 for year 1, year 2 and year 3, alright. What is year 7? I mean number 7 in year 1? Number 7 in year 1 indicates a cash flow of 20,000, alright. Number 4 in year 2 indicates a cash flow of 30,000, and number 9 in year 3 indicates a cash flow of 30,000, alright. These cash flows are discounted at a cost of capital of 15%, and I get cash flows in present value terms. I total it up and I get present value of cash inflows as 59,000, 59 minus my outflow of 42, I get an NPV of 17,000, which is positive, right. Similarly, I keep on repeating simulation run 1, 2, 3, 4 and 5, and what you will notice is that we will get 4 positive NPVs out of 5, right, and hence 4 by 5 is an 80% chance that this project will yield a positive NPV. Now, obviously, practically, we are not going to do these simulation runs manually on Excel like this. We will do this in Excel by running, a code, and clearly we will do more than 5 simulation runs, probably we will do a few thousand runs, and hence the level of confidence in simulation as a technique will increase, right. I would request you all to work on simulation run 3, 4 and 5. The remaining 3 runs, you should try it out and see whether you get a positive or a negative NPV, alright. I will share this sheet with you all, and hence you can work out the remaining 3 runs. The cells are left, blank out over here, so that you can fill in and calculate NPV for the remaining 3 runs. But as I said, you will notice that out of 5 NPVs, 4 would be positive and the 5th one would be negative, resulting into an 80% chance of a positive NPV and a 20% chance of a negative NPV, right. I hope simulation as a technique is clear. It gives you that level of confidence to trust in your expected NPV, basis which you can now accept or reject a project. Now, obviously, there is no thumb rule which says that you accept projects with 80% positive NPV probabilities, alright. That depends upon your risk appetite. It depends upon your company's risk averse or risk appetite. It It also depends upon the economic situation that your country is going through and your company is going through, basis which you will say that is this level of risk acceptable or not. But at least as a technique, simulation delivers a degree of insight which was more than what we just did earlier on by calculating expected NPV. I am good to take your questions. Thank you.